Hi to everyone, this is your Shankarappa sir. In today's session, we will discuss about the applications of the Magic Tea applications. So in this first one, this Magic Tea can be used as a measurement of impedance. That means this Magic Tea can be used to measure the unknown impedance. Second one, Magic Tea can be used as a duplexer. And third one, this Magic Tea can be used as a mixer. So these are the applications of the Magic Tea. So this Magic Tea can be used to measure the unknown impedance. Magic Tea can be used as a duplexer, and Magic Tea can be used as a mixer. Now we can see one by one. Now the first one, measurement of impedance by using the Magic Tea. Unknown impedance can be measured by using the Magic Tea. So it is a Magic Tea to which source 1, port 1 and port 2 are to be connected with the impedances. Port 1 will be connected to the standard variable known impedance, and the port 2 is to be connected with the unknown impedance. Port 3 with the microwave source, and the port 4 will be a null detector. Now, when through the microwave source a power is to be applied, signal is to be applied as A3, a energy is to be applied or power is to be applied as A3, it splits up between 1 and 2 with equal magnitude, because port 3 is the H plane T and port 4 is the E plane T. The property of H plane T, whatever the power is to be given through that particular port, it splits between the other two ports with equal magnitude and in phase. So the A3 will be divided between 1 and 2, between the ports 1 and 2 with equal magnitude. Now, these ports 1 and 2 are to be terminated with the impedances Z1 and Z2. They are not to be equal to the characteristic impedance. The termination impedances of Z1 and Z2 are not to be equal to the characteristic impedance Z0. Hence, there is a possibility of reflection. Let ρ1 and ρ2 be the reflection due to the port 1 and port 2. Then, the reflected power through port 1 is 1 by root 2 A3 ρ1, and through the port 2 it is 1 by root 2 A3 ρ2. And these two will enter into the port 4. It is to be entering in this direction and it is to be entering in this direction. They are to be in the opposite direction. Therefore, whatever the power is there through the port 1 and port 2, that will be the additive property at port 4, because it is the E plane T. That is a property of E plane T. So, the reflected powers 1 by root 2 A3 ρ1 and 1 by root 2 A3 ρ2 will be entered into the null detector with opposite phase. That is 1 by root 2 into 1 by root 2 A3 ρ1 minus 1 by root 2 into 1 by root 2 A3 ρ2. The null detector becomes to be the null. Null means 0. The net deflection can be obtained by adding these two. That is 1 by root 2 into 1 by root 2 A3 ρ1 minus 1 by root 2 into 1 by root 2 A3 ρ2 will be equal to 0. Now, the net wave reaching the null detector is 1 by root 2 into 1 by root 2 A3 ρ1 minus 1 by root 2 into 1 by root 2 A3 ρ2 will be equal to 0. By solving this, you can have it is 1 by 2 into A3 ρ1 minus 1 by 2 A3 ρ2 will be equal to 0. Otherwise, ρ1 minus ρ2 equal to 0. Otherwise, ρ1 equal to ρ2. ρ1 is the reflection coefficient of the port 1 and ρ2 is the reflection coefficient of the port 2. This ρ1 equal to ρ2, which implies Z1 minus ZZ by Z1 plus ZZ will be equal to Z2 minus ZZ by Z2 plus ZZ. Which implies by solving all the things you can have Z1 equal to Z2. Otherwise R1 plus JX1 will be equal to R2 plus JX2. Which implies R1 equal to R2 and X1 equal to X2. Therefore, the unknown impedance can be determined by using this magic T. So, R1 and R2 are the resistances, X1, X2 are the reactances of port 1 and port 2. The unknown impedance can be determined by adjusting this standard variable impedance till the bridge becomes to be the balanced and both the impedances become to be equal. Both the impedances becomes to be equal. Now the second one, magic T can be used as a duplexer. So in this, port 1 and port 2 are to be connected with microwave source and transmitter respectively. Port 3 will be the terminated load, matched load, and port 4 is to be connected with an antenna. While transmitting, a transmitter will transmit the signal. So in this, half of the signal will pass towards to the antenna and the other half will move towards to the port 3. Port 3 is the terminated load. It will be completely absorbed. No power is to be reflected. But there is no power reaching to the port 1 because in a magic T, port 1 and port 2 are the isolated ports. Now, antenna is receiving the power. This received power will retransmit the signal. In that, half of the power will reach to the microwave source and the other half will reach to the transmitter. Now you can observe the transmitter initially it is transmitting and later it is to be receiving. Both the operations are to be performed by using this device. Hence, we can say that magic T can be used as a duplexer. Dual operation, both the operations can be performed by using this device, by using this system. Here transmitter will perform transmission and reception and antenna will perform receives and retransmits the signal. Hence, it is a duplexer. Now, the third one is a magic T as a mixer. This magic T can also be used in the microwave receivers as a mixer. So, here port 1 and port 2 are to be connected with the mixer and matched load. Port 3 with the local oscillator and port 4 with an antenna. H-arm with a local oscillator and E-arm with an antenna. This local oscillator will generate the frequency of F0 and this antenna will transmit the signal having the frequency of Fin. These Fin and F0 will move towards to the mixer to generate the intermediate frequency IF as IF equal to Fin minus F0. Fin minus F0. Along these applications, this magic T has other applications also, such as microwave discriminator and microwave bridge, etc. So these are the applications of the magic T. I am requesting you all share, subscribe and like my videos for more and more videos which are to be useful for the referrals and the number of students. Thank you all.